In our laboratory, iDARE laboratory, it is the acronym for Innovation and Development on Antennas, Radars and Electromagnetics. We are essentially developing solutions for a variety of applied electromagnetic problems. And these problems span in the areas which are important for the community, like next generation communication technology. Then we have the security and defense aspects, as well as healthcare and various applications which are essentially coming from that. So our research philosophy essentially strikes a blend or balance between different aspects. So one side is design of various hardware components like antennas and meta surfaces and the associated circuitries that come along with that. For this design purpose, we need to use some commercial full wave electromagnetic tools, and then we have to back it up with fabrication and measurement on these prototypes. Then another part of this our research is basically use of different new algorithms to enhance the functionality of these computational electromagnetic solvers. So for example, we are using finite difference time domain method for analyzing the wave matter interaction in time varying media. And similarly, we are applying infinitesimal dipole modeling and similar things to essentially analyze the near field behavior of electrically large antenna arrays. So this is the second stage of the research. And another aspect which we focus a lot is after building these components, these antennas or meta surfaces, we would like to integrate them in some practical system. It may be some basic lab scale communication system with some software defined radios. It could be some radar hardware, signal processing hardware, where we can place these meta surface or radomes and check the performance of the thing. So the system level analysis comes. So component level, then algorithm level and system level. These are the three directions in the overall research area. So one of our project that has emerged from an ongoing project with ACRB. So I got a startup grant from ACRB, currently ANRF, on this space-time modulated meta surface, where we basically explored the various space-time modulation techniques of these meta surfaces, what we can achieve by spatially modulating a structure and whether we can extend it for some beam forming or anomalous beam steering. And then what are the effects of the time modulation of this meta surface, what type of nonlinear mixing, on-air mixing, as well as time varying transmission lines we can build using it. So these were mostly an exploratory type of research that we did. Now, based on the outcomes of this ACRB funded project, currently we are having some projects funded from ISRO through the Space Technology Cell of ISC, and as well as from DRDO. So one of them is from the AD lab of DRDO, and one more project is under the pipeline from LRD. So they are mostly looking into building metasurface based beam steering antennas for the higher frequencies like the radar bands, KU band, KA band, where conventional phase shifter based technology as well as the conventional refractor based technology, they can have some, I would say, demerits. So where these metasurface antennas could come into the picture. And the application of these antennas are like from ground to space communications, or in many cases, they can also be built on top of some high altitude platform stations. So this has implications also in the context of 6G non-terrestrial networks. Another project which is basically through a collaboration with Astra Micros Private Limited that we are having. I am having one MTech ERP student from Astra. So there we are looking to build these active phased arrays in S band and X band for a variety of applications, not only communication but also others. And the new thing about the work is we are trying to deploy some dual band or multi-band, multi-mode type of microstrip patch elements where we can maintain the compactness but still achieve this multi-frequency functionality. And we also adopted some of our patented technology where we can reduce the higher order modes from these microstrip patches. So that is another direction where we have explored. And I mean, it is kind of ongoing. Then through the Infosys Young Investigator grant which I obtained, we explored this antenna design for full duplex communication system, which is also a very pertinent thing for 6G technology, because using full duplex communication we can improve the spectral efficiency, reduce the latency. But implementing a full duplex communication system has a lot of hardware challenges as well as software challenges. So we are mostly looking into the hardware side of it and trying to cancel the self interference in the hardware level. So that is one more direction. And another application that we are looking into is basically in the automotive MIMO radar sector. So this is a technology that has become a very applied and pertinent these days, because all of our vehicles which are enabled with these advanced driver assistance systems, they have this automotive MIMO radar. However, deployment of this automotive MIMO radar in many cases poses several challenges. Basically, placement of these systems before some like car structure, maybe bumper or similar type of radomes. So we have explored that through one of our SID funded works, and then recently many of our students are working with Texas Instruments through the TI Scholar program and looking into some of these designs, some of these antenna design as well as antenna radome analysis using variety of computational electromagnetic tools. So in terms of emerging research areas, we can segment it into the two parts. One is design of these multiple antenna systems. It can be MIMO or it can be full duplex, electrically large aperture arrays. This for communication, sensing and imaging applications. And here also recently the topic of reconfigurable intelligent surface, this has emerged as a very hot area of research nowadays. So reconfigurable intelligent surface, or RIS, this is one special case of meta surfaces, and this can be used not only for enhancing communication functionalities, but also many of the imaging and sensing applications as well as energy harvesting applications. So in terms of like future directions, this RIS has lot of potential because it caters to the interdisciplinary requirement of antennas, signal processing, communication. So many of my colleagues in this department are working on the signal processing and communication aspect of it. Now we are trying to complement their work by working on the hardware side, which can lead to very exciting applications. Now, another spin-off from this is use of these meta-surface antennas for 6G non-terrestrial networks. One more area which some of my students and postdocs have worked, and we have ongoing research on it, is the design of wearable and implantable antennas and sensors for biomedical applications. And this has huge implications in terms of the healthcare, because not only we can monitor various vital states like blood glucose and many of these things, but also we can perform biotelemetry, get some of these data from those implanted devices back to systems, and we can do wireless charging of pacemakers, and at the same time like use of this catheter based systems for heating up selective ablations of tissues for hypothermia. So these are very crucial areas, particularly because nowadays the aspect of collaboration with the medical institutes and biosciences is very much important, and these applied electromagnetic research direction play a vital role in that. The research ecosystem in ECE is extremely interdisciplinary in nature, because we have experts who are working in signal processing, who are working in the communication system design, communication related algorithms, networks, AI ML, and photonics, as well as RF and microwave systems. So there is a lot of scope for interdepartmental collaboration, which we regularly do, and we get useful knowledge exchange. Just as an example, I can cite about some projects that we had with Professor Gaurav Banerjee's ARSL lab. It was facilitated by the students who are working in these two labs, our lab and their lab. So we worked on basically antenna design for some of their S-band radar systems for the through wall imaging, And at the same time, the meta surfaces that we built, time varying meta surfaces we built for some different applications. So one of the functionality, like whether it can spoof the application of some Doppler radar, these things we can do and check with the systems that Gaurav has in his lab. So this is just one example, and similar many other such projects are in the pipeline where the RIS hardware that we are developing can be used for experiments as well as algorithm development for my colleagues who are working in communication system design and imaging applications. So this type of collaboration environment is very special about ECE. And another important aspect is the areas where we are working on are important areas from national importance as well as in the global markets, and it is funded from various multinational companies. There are multiple grants which are there in the department, as well as lot of interest from ISRO, DRDO, and BEL from indigenous development of many of these technologies. Let it be the Bharat 6G mission, or let it be some other relevant areas, like for example the drone detection radar. So this type of huge funding and opportunities that are there in terms of the exposure from the Indian as well as global market is again which makes EC stand out in many of these things. So I can tell about the career opportunities for the students who might be interested in the areas where I am working on, these antennas and propagation as well as microwave theory as well as techniques. So there are, first of all, after graduation, let us say from after doing masters from here, there is a huge opportunity of doing PhD from abroad. But at the same time, the PhD students who are working in these areas, there are a lot of requirement of skilled manpowers in these RF and microwave technology related areas, because not only this is important from the communication system building, like we are looking into indigenous development of this 6G and beyond for India. At the same time, these areas are of lot of strategic relevance for space research and defense related research. So the expertise in antennas and propagation as well as microwave is of paramount importance for the students, and it is required actually by many of these agencies, and many startups are also coming up. Now we have the Indian Semiconductor Mission and lot of fabless chip designers and RFIC working companies. They are, focusing. So there will be a lot of requirement of skilled manpowers. So pursuing higher studies in these areas is going to be very important, in my opinion, in next 1 or 2 decades. Yes. So as I told earlier, like our works are focusing on building many of these microwave and millimeter wave antennas and meta surfaces for a variety of applications. In terms of societal application, as you can figure out, if I talk about 6G communication, the current focus are ubiquitous connectivity and affordable communication systems and low cost communication systems. So this all of these aspects are very important, particularly if I look from the Indian societal application thing, that in the rural connectivity we would require many of these non-terrestrial networks to fill up the gaps or to at least complement the conventional terrestrial networks. So the hardware that we are designing, which are potentially going to be deployed for the 6G systems, are going to be very much useful in bridging this connectivity between rural and urban areas, so bridge the rural urban divide, and also provide affordable and low cost communication systems for many users, and based on the connectivity that can help in financial transactions or medical consultations. Many of these things can be facilitated by this technology. So this is a very important societal application as I can think of. Then comes the area of healthcare. So the systems that we are building, not only the implanted antennas, but also many of the radar systems which can be used for let us say, monitoring of health for the elderly. So the areas that we are working on have direct relevance in the context of healthcare. At the same time, we can sense many of the parameters like blood glucose level or oxygen level. Many of these things can be sensed by the technologies that we are focusing on in terms of future research. And another I would probably focus on is the area of security, right? So nowadays we are all knowing that use of unmanned aerial vehicles and drones are very much prevalent, and many of our works are focusing on how to detect these unmanned aerial vehicles or some object using low cost radars. And if we can manage to do them, then that has very much relevance in the sensing of these drones, can actually help improve the security, not only for some specific, like maybe a police station or maybe an army area, but also some of the facilities like maybe a hotel or some of these things. So this I can briefly tell that these are the direct social relevance of the work that we are currently doing. So I can divide the lab facilities into two parts. One is the software facilities that we have the licensed versions, and another segment is the hardware measurement instruments that we are having. So in terms of the software, we are having CST Microwave Studio licenses, and with collaborating with Professor Binoy, we now have, I think, around 20 to 25 licenses, educational purpose, which people can use. And many of my colleagues who are working on similar areas have already like made use of some of these licenses for their projects, because CST Microwave Studio is a full wave solver that can solve a large number of problems, starting from antenna design to circuit analysis, as well as many of the propagation modeling things also can be done given good compute facilities there. Similarly, we also do have these ADS, Keysight ADS software, which is able to solve or simulate many of the circuits operating in microwave and millimeter wave frequencies. Then comes the hardware part. So in terms of hardware, one of the key facilities that we make use of is this Keysight VNA. So although in the department we do have VNAs in the lab of Professor Binoy as well as Professor Gaurav Banerjee, but this one is a portable one which can be used for not only for this indoor, but it can also be moved outdoors for doing this scattering parameter analysis or channel modeling applications. And some of our students are already focusing on some of this research, and this can be shared, and not only within the department but also can be used by startups who might be are interested to measure some of these parameters for their filters or maybe their antennas and devices like that. Then in terms of measurement, we are having this newly procured millimeter wave horn antennas as well as this horn antenna, which can be used for anechoic chamber based antenna characterization experiments. And we are also having a number of these software defined radios. As I told, one of our research objective is to analyze the system level things. So we would like to integrate our antennas as well as meta surface for using this this type of like software defined radios to check the channel parameters and to do some useful system level analysis. And these are some of the hardwares that have been developed. This is one frequency selective radome, which is working in the X-band frequencies, and this is a space-time modulated like meta surface that can change into multiple scattering states. This is also a recently published work. And then these are the anomalous reflecting screens. So this we have designed for a variety of frequencies, like from X band, then in the C band, as well as in the 26 GHz. So K band also we are focusing on. This is one time modulated meta surface which have been designed. So many of the details of our work and the relevant publications from this are available in our lab website. So, conferences, the students are basically like focusing on not only the national conferences, but a multiple of these international conferences where our students regularly go. So in our area, it is mostly we are having the IEEE Antennas and Propagation Society and IEEE Microwave Theory and Technology Society conferences. So the two major conferences of IEEE MTTS, as we call, one is the IMS, and then we have that which is generally held in the US, and we have European Microwave Conference. So this IMS and European Microwave Conference, our students have participated. Then in the Antenna Propagation Society side, we have the Antennas and Propagation Symposium, which generally, I mean, is held in US, but this year it was held in Florence, Italy. So there also our student has presented paper. And we have European Conference on Antennas and Propagation, where our student participates. So these are, I would say, the major international conferences in the in the global scale where our student participate. And in the national scale, we have a lot of conferences. Among them, I think a very popular and large conference is MapCon, where also our students regularly go and they present their work, they participate in the PhD student initiative and various things. And fortunately, we are also lucky that many of the times in these conferences, MAMCON, WAMS, and our students have got best paper awards. Okay, and so this is, I would say, they are engaging a lot with the broader community, IEEE community. And they have also, particularly the students in our lab and associated with some of the other labs, they have opened one IEEE student branch chapter, which is also good for their networking with various national and international entities. Yes. Yeah, so placement opportunities in the context of our research areas, which is again mostly in this antenna propagation and like microwave theory and techniques or technology domain. So as I mentioned, many of these communication and circuits related companies, starting from Qualcomm, Intel, TI, and Cisco, they regularly have requirements for RF and microwave engineers. And so there is an ample opportunity of getting a job in those multinational companies. At the same time, there are routes by which people can explore the career opportunities in R&D labs, like in ISRO and DRDO. There are multiple such labs. So through some collaboration, through some exchange, these things are facilitated. So for that purpose, we are also having a lot of interaction with this ISRO and DRDO, as well as Bharat Electronics Limited.